Okay, let's talk about section 3.10, trig, equations and inequalities, all right? First thing I want you to know is that we're focusing on a restricted domain today. So this is a case that you're going to need to be familiar with. And in this case, this restricted domain is we're just going to be talking about values that end in between 0 and 2 pi. So we're not talking about negatives and we're not talking about anything past 2 pi. So let's go ahead and talk about exact values. Exact values mean that we're not going to be using a calculator, okay? So let's go ahead and solve for x using these exact values. So we're going to solve for x just like we were solving in algebra. We're going to subtract the 5 over. So we get 2 sine x equals -1. Divide both sides by 2, so we end up with, hey, sine x equals -1. In order to get the sine off of x, we're going to take the inverse sine. Whatever we do to one side, we do to the other. So we get x equals the inverse sine of -1/2. Keep in mind, we're talking about all values between 0 and 2 pi. That's a full circle, okay? We're not just restricting it to its primary values of arc sine. So we are looking at all values between 0 and 2 pi. So keep in mind, I'm looking for where will sine be negative. Well, I know sine is negative in the third and the fourth quadrants. I also know that sine is 1/2. Remember in our chart here, sine is 1/2 in that pi over 6 value. So I know from here to here is a pi over 6 as well as this. So what do we specifically call those two angles at a pi over 6? Well, I know here is 1 pi. We could also call that 6 pi over 6. And if I add down pi over 6, we get 7 pi over 6 is one value. And the other value, if this is 2 pi, another way of saying that is 12 pi over 6. And if I subtract back 1 pi over 6, we get 11 pi over 6. So these are the values between 0 and 2 pi that satisfy this equation. All right, so then how do we talk about approximate values, again, with a restricted domain between 0 and 2 pi? We can use calc. Okay, so to get approximate evaluation, we are going to be using a calculator, so make sure you have that ready to go, okay? Also, when we're talking about approximate values, I just want to remind you when we're working with the unit circle, this is 0, this is pi, but remember the approximate value for pi is 3.14, and all the way around the circle is 2 pi, aka 6.28. At the top here is pi over 2, which is about 1.57, and at the bottom, 3 pi over 2 is 4.71. So just a quick remembering of that those are the approximate values that we're going to be using with our calculator. Okay, so first things first, when I look at this gets a little scary. I see tangent x squared and tangent. I'm going to teach you a strategy that you will use a lot moving forward. We call this, in calculus, we call this U substitution, where when we see something squared and then that value alone before it's squared in the middle, we say let U equal whatever that value is in the middle. So we're going to say let U equals tangent x. Now we're going to rewrite this equation letting U equal tangent x. Well, if I know tangent x or tangent squared x could be saying U squared, right? So if U is tangent, tangent squared would be U squared plus 2 times tangent x, well, that's just U, minus 8 equals 0. We're going to factor this just like we did in algebra, knowing that if we have 3 terms, we can use x factoring what multiplies to 8 and adds to 2. We know those two values are 2 and 4, -2 and 4. So I know U plus 4 times U minus 2 will equal 0. Go ahead and solve that. So we would get U equals -4 as well as U equals 2. But remember, we're trying to solve for this. We're trying to solve for tangent x. So remember, now we're going to substitute back that U isn't actually U. U is tangent x. So we're actually going to say U is tangent x should equal -4, and U is also tangent x, which should equal 2. So now let's talk about, okay, what values would tangent x equal -4 at? What values would tangent x equal 2 at? Okay, so if I'm using this, we're going to use your calculator. So in your calc, we're going to get that tangent to the other side. So we're going to take the inverse tangent on both sides. So x equals the inverse tan of -4, and x equals the inverse tangent of 2. So on this part here, I know in my calculator that x equals -1.325. Okay, so if I look at that though, remember that my restricted domain says this, hey, whatever your values of x are have to be between 0 and 2 pi. For us, that's 0 and 6.28. This is out of the domain. So does that mean that we're out of luck? No, because we know that even though it's out of the domain, we can find that same value or that same location on the circle within our domain. So if we look at this circle, we know if this is 0, and this is, we'll say negative 1.57 is here, we know that negative 1.325 would be here. So how can I say this location in a positive value? So if I wanted to get back to this from this negative 1.25, if I added 2 pi to it, that would get me back to that same value. So let's see what it would be, a coterminal angle or the same type of angle. If I add 2 pi to it, put it in your calculator, we get this. This would be 4.957, which is inside our restricted domain between 0 and 2 pi, or 0 and 6.28. Okay, so I know, hey, tangent will equal -4 here at this point. I also know that because we're talking about a full positive circle, that tangent's also negative in the second quadrant, okay? So if I take this value and I subtract a full pi to this value here, tangent will also equal -4 at 4.957, and we're also going to subtract pi, which is 1.815. So when does tangent equal -4? When x equals 4.957 and at 1.815. Okay? All right, let's look at the other case here. When does tangent inverse tangent equal 2? Well, if I plug that in my calculator, I get x equals 1.107. So remember, that's going to give me here in the first quadrant 1.107. Well, I know also in a full circle, pi away from that, tangent is also going to be positive. So if I add a pi to that value, we get here. So 1.107 plus pi will also equal 4.248. So for all of our values between 0 and 6.28, we can see a value of x could be at 4.957, 1.815, 1.107, and 4.248. I'm going to put that in numerical order. And these are our 4 values where our original function, tangent squared x plus 2 tangent x minus 8 equals 0, from 0 to 2 pi. You can also graph this in your calculator, like literally type this in and see where it will equal 0 on that intersection, and you'll get those 4 specific values. All right, so now we're going to move from a restricted value to all values. Okay, so these are all values. This means forever, not just one positive circle, but all the values forever. So let's talk about those exact values. Remember, again, for exact values, we're not going to be using a calculator here. What's nice about this, theta is by itself. We don't have to worry about other terms, cosine, theta, whatever. So we're going to solve this directly. I'm going to divide by 4. So I get a cosine squared theta equals 1/2 by reducing it. And we're going to take the square root of both sides. Remember, take the square root of both sides means when I write the square root, you take plus or minus. So this becomes cosine theta equals plus or minus the root of 1/2. Well, remember that cosine of, or just root of 1/2 is like saying the root of 1 over the root of 2, which is positive 1 over the root of 2. If I rationalize this, I'm going to have to multiply by root 2 on both top and bottom, and we end up with plus or minus root 2 over 2. In order to solve for theta here, we're going to take the inverse cosine on both sides. So I'm asking myself, hey, where does theta give me that cosine will be both positive and negative root 2. So let's look at where that might be. So if it's both positive and negative, I know cosine will be positive in the first and the fourth. I also know cosine will be negative in the second and the third as well. So a cosine theta would be root 2 over 2 at plus or minus positive, or plus or minus pi over 4. So if this is pi over 4 here, this angle, a pi over 4 in this region right here would give me 3 pi over 4. A pi over 4 in the third quadrant would give me 5 pi over 4. And a pi over 4 in the fourth quadrant would give me 7 pi over 4. And so how do we say, that's within 0 to 2 pi, but how do we say every value of theta that would equal positive or negative root 2 over 2 forever? So I know that my initial one is right here. That's at pi over 4. And I know if I add pi, we'll get back to here. So we're going to say, hey, theta could be every pi over 4 plus pi n, where n is any integer, that goes forever. We can also say that it happens here at 3 pi over 4, and if I add another pi, it gives me back to 7 pi over 4. So we can say it also happens every 3 pi over 4 plus pi n forever as well. All right, so let's look at this one. Again, we're looking at all values, not just positive values between 0 and 2 pi. So let's go ahead and solve this. Keep in mind, anytime you have your variable squared and a single variable, we cannot just divide this out. We need to set this equal to 0. So I'm going to subtract sine theta from both sides. So we've got 0 on this side of the equation, the right side, equals 3 sine squared theta minus sine theta. Okay, so you could either use u substitution to make it more simple for you, but I can also recognize that I see sine theta for both of these. This is going to be your greatest common factor. So sine theta times 3 sine theta would give me back 3 squared, or 3 sine squared theta, minus 1 would give me back that sine theta. So again, we know that anytime you've got a product equaling 0, we're going to use our 0 product property, where we can set each of those equal to 0. So I'm going to say, well, sine theta can equal 0, and also 3 sine theta minus 1 also can equal 0. Let's go ahead and solve these directly. Well, I know to take the inverse sine of both sides if I want to get sine by itself or theta by itself. So I get theta equals the inverse sine of 0. Remember, because we're using an approximate value, you can use your calculator, okay? Our calculator will tell me that it happens at pi. Okay, so I know sine theta equals pi at, or 0 at 0. It also happens 1 pi away, because we're looking for all of the values, because remember these values at 1, 0 and negative 1, 0, cosine, comma, sine, they happen here and here. So I know it happens at 0, and then it will happen again plus pi, and then another plus pi, and so on. So we can call that, this is theta equals 0 plus pi times n. To simplify that, we could just call that pi, every pi n, where n is any integer. Okay, we also have the right side here. So let's use algebra. We're going to add 1 to both sides. So we get 3 sine theta equals 1. Divide both sides by 3. And we get sine theta equals 1/3. To get sine off of theta, we're going to use inverse sine on both sides. So we get theta equals the inverse sine of 1/3. Keep in mind, we're looking for every value forever. If I plug this into my calculator, I get theta equals 0.339. Let's go ahead and sketch what this looks like. I know 0.339 is right here. That's where sine is positive. I also know that sine is positive here. So if this is 0.339, I know this is also 0.339 from pi. So remember, if this is from pi upwards, from there is 0.339, I know that this point right here is pi minus 0.339. If I take that 3.14, subtract the 0.339, we get 2.801. So if I know this is 2.801, but I'm looking for every value, I can take this 0.339 and add every 2 pi to it to get back to that value. I can also start here and add 2 pi to it. So we're going to say, hey, theta for every value is going to be 0.339 plus 2 pi n, as well as 2.801 plus 2 pi n. And this will give me, actually all three of these give me where theta is satisfying every value of theta that will make this true. You can also plug this into your calculator and look at its graph. All right, let's go ahead and look at the next page. So this time we're talking about solving trig identities with the restricted domain from 0 to 2 pi. Again, that means not forever. That means it's just within those positive values of 0 and 2 pi. So let's look at our exact values. Remember, this means no calculator. Okay, we're going to solve this because we're just talking about a singular cosine x not squared. We can solve it directly. Add the 1 to both sides. We get 4 cosine x is less than or equal to -2. Divide both sides by 4. And we've got cosine x is less than or equal to -1/2. Okay, to get x by itself, we're going to take the inverse cosine of both sides. So we're looking for where is it less than or equal to inverse cosine of -1/2? Okay, so we need to find what those actual values are, right? So remember, I'm going to include that rough sketch of what cosine typically looks like. I know it looks like this, right? Where this is -1, here's 1. We end here at 2 pi. Okay, I know if I'm looking for where cosine is -1/2, if this is -1/2 is about right here. So I want to know, okay, where are these values here and here? So we know we can find these values. Remember, all students take calc. I'm here sine and cosine. We know 1, 2, 3, 3, 2, 1 happens here at pi over 3. So we know in the second quadrant, cosine is negative, also the third quadrant. So what's a pi over 3 here? Well, this is going to be 2 pi over 3. And a pi over 3 angle in the third quadrant, it looks like 4 pi over 3. And if you see here, I know that this is going to be 2 pi over 3. And this value here is 4 pi over 3. So what do we say? We're looking for where x is less than or equal to. So this is our equal to 1/2, but it's also less than here. So we know, okay, between 2 pi over 3 and 4 pi over 3, that value of x will be less than or equal to that -1/2. All right, and then let's go ahead and look at all exact values. Remember that this goes on forever, not just between 0 and 2 pi. Let's go ahead and solve it. Let's go ahead and solve this directly. We don't have a cosine squared, so we're just going to subtract the 4 to both sides. So cosine of 2 theta equals 0. Take the inverse cosine of both sides. So we get 2 theta equals the inverse of 0. So if we're looking at this, the inverse cosine of 0, so hey, where does cosine equal 0? Well, I know this value is 1, 0 cosine sine. So this is 0, 1 cosine sine. That's here. We also know that sine will equal, or that cosine will equal 0 here. So we see it's happening when we have pi forever, so that's going to be pi plus 2 pi n, as well as, oh sorry, this is 2 pi over 2 and 3 pi over 2. That's this location here, plus 2 pi n. Okay, we actually can summarize this as well as if I start here at pi over 2, if I add 1 pi, we'll get to that 3 pi over 2, and if I add pi again, I'll get back to it. So I can summarize this as just saying, hey, if I just start at pi over 2, I can add pi n. It will give me every single value. Keep in mind that we just found 2 theta, not theta. So now we're going to continue to solve by dividing everything by 2. So theta will equal pi over 2 divided by 2 is just pi over 4. And then that plus pi n divided by 2 will give me pi over 2 times n. And this will give you every value forever of theta that satisfies this equation. All right, you guys, that's it.